The topic of this video will be the addition of halogens to alkenes. The general reaction is an alkene reacting with a molecule of halogen. The halogen adds across the double bond so that one atom of halogen adds to one carbon of the double bond and the other adds to the other carbon. This mechanism leads to anti-addition. Therefore, it is a stereospecific reaction. This is due to the mechanism. Let's look at that mechanism now. First, the alkene attacks one atom of the halogen. This kicks off the other atom of the halogen as the leaving group. The product of this step is called a halonium ion. The other product of this step is the halide. In the next step, the halide attacks the halonium ion. Producing the anti-product. Now let's look at a specific reaction. When this alkene is reacted with bromine, it produces two products, two enantiomers that are both trans. We do not see the cis isomer. Now let's look at the mechanism. In the first step of the mechanism, the alkene attacks the halide, kicking off the leaving group and forming the bromonium ion. The bromonium ion can be attacked in one of two ways by the halide that is formed in the first step. I have redrawn the bromonium ion so that we're looking at it from the side, and the bromonium ion is pointing down. Bromide can attack the right carbon of the bromonium ion. It has to attack from the top because the leaving group is on the bottom. This results in the stereoisomer, where the bromine on the right carbon is pointing up and the bromine on the left carbon is pointing down. This is the same as the product isomer that we drew on the left. The other option is that the bromide can attack the carbon on the left of the bromonium ion. This results in the enantiomeric product. In other words, the product on the right. The product, therefore, of the reaction of this alkene with bromine gives us a pair of enantiomers, not the other stereoisomer that could be formed. Notice that with the addition of halogens to an alkene, you don't need to worry about regiochemistry because we're adding the same atom to each carbon of the alkene. We only have to worry about the stereochemical outcome.